Welcome back to the, I think, fourth part overall and third part of the, wet and hot parts. And this time we're gonna wire up everything inside here. And we are doing some basic tests. So, of course, we will measure if our grounding, main earth is okay, and if our thermal cutout is actually working. Last resort here if anything should go wrong. Let's get started. Talking about getting started, I started without you by fiddling in that main earth cable into the center pin of the connector. And now I shall try to solder that in. And with these connectors, they are just hollow pins, but they have a hole right here in the end. So if I put a little bit of solder on here just for better transfer of the heat, and I heat up the pin, at some point I should be able to feed into the hole. Can you see that? Solder. That's really quite easy until it's full to the brim. That should do the job. Maybe I've overdone it. No worries. I will zoom out in a moment, but I thought you might want to see that. I can just get the excess off, hopefully, or not. Sorry. Gonna reach for something a little bit more suitable for the job. Clean that pin up real nice, or at least I'm trying to. Okay, I guess that's is as good as it gets. Okay, live is supposed to go via quick connect to that lower pin here. So let me fiddle with that a little bit. I'm sorry, but I couldn't possibly have filmed that. Getting to that pin was quite awkward, and I had to remove the screw here to get in with a soldering iron. That was, the reason I made that hole here on the inner side of that piece a little bit larger to have better access. But these down pins here, they will give me trouble. Anyway, let's continue. The next lead should be a little bit easier. It will go somewhere here, and will be neutral to both of the heating elements. Just making sure this goes in here and does not stick out too much. Well, just perfect. And I just have to bend it until I'm about-ish here and bend it again. So I'm about-ish here. Yeah, there should be no strain. This should be falling natural in place. No strain in the wire. Okay. So about-ish here. And yeah, get the isolation off, yeah, heat shrink tape, and then we take the correct two connection and solder it together and heat shrink it. Let's try it. That was actually not that easy. Yeah, again, my hands were in the way. Anyway, let's try to give you a close-up how I soldered that pin. This time, yeah, without getting in the way. Believe me, that angle is not as awkward for you as it is awkward for me. Ooh, that's an ugly blob, huh? The last connection should be easy again. Yeah, just, yeah, crimp that into a spade connector and it goes to the other end of the thermal cutout. So, and that was all that is to the AC mains wiring. Okay, let's continue with the two DS18B20 sensors here and oh, you can't see that, sorry. Here. Okay, I have no idea if this is filming correctly, but anyway, I hope this gets into focus. I packed the first temperature sensor into some, can I have a focus? Is that in focus? Oh, anyway, in some insulation material, and yeah, it will go into that corner here, and yeah, there's a hold down, and I will attach now some leads. Just a short update in between. I packed the second sensor also in some insulation material, and that's the same stuff I used. The same stuff I used in the prototype, and it's yeah, I tested it once with the at 150 degrees, and yeah, it can take it. So that should be nice and fine, and yeah. I bundled the cables a little bit, and yeah, now I will start fiddling, getting the whole cable bundle here to the front, to the connector. Soldering all that in was a pain in the, you know, beyond back. Yeah, I had the connector out, in fact, and yeah, it was a mess. I broke that spade connector here. Didn't know how I managed that, but yeah, fiddled around with it a little bit too much, I guess. And yeah, anyway, everything is soldered in now, and now we can attach the sensors. However, I will also put a little bit of that heat conducting silicone adhesive on the bottom, just to, yeah, make things a little bit more heat conductive. Okay, sensors are glued and screwed down, yeah, both of them. Yeah, the only thing missing now is, of course, a cable. Let's do that. It's much easier to solder these connectors when you can actually access the pins. Yeah, Still a bit tricky, but yeah, looks better than the inside one. And of course, if I zoom out, yeah, there's a cable attached to it. So I will close that up now. You know that you bought some sturdy connector when you actually, come on, need something like that to close it up. And I'm not sure if not the inside is now rotating. Yeah, it is. And if that is already enough, or if I can go a little further. Okay. That should do it. Yeah, grommet. It's a good fit. And now I need a second pair of pliers. It's getting a little bit crowded here around the camera. So, grommet is extruding here, and yeah, that's it. That's a heavy duty industrial watertight IP whatever connector, and I chosen a silicon cable. I mean, first of all, it's heat resistant. Second of all, in Germany, these multi-conductor cables are very cheaply available on eBay. They are called sauna cables, and a silicon cable, of course, it's very flexible, which will be nice. Okay, I think we're done on the black bench. So we're back on the white bench. Everything is, yeah, finished so far, but now it's time to do some tests. And we'll first start with, yeah, simply taking the ohmmeter and measuring some resistances here. And I do have a wiring plan, okay, with yeah, the color codes I use. There are different color codes for, yeah, inside the case and yeah, outside the case on the cable, and everything is color coded here. And I don't know if you can see that, but there are actually numbers here on the single wires. And also inside these connectors, ooh, yeah, you can see that 1, 2, 3, 4, 5, 6. It's all numbered. So let's start. Our mains earth should be connected to basically nothing. Or is my ohmmeter working? Yeah, it is. Yeah, I got everything, some of them twice. Doesn't matter. Next, we should have a connection between mains neutral and mains live. Yeah, that's my heating elements in parallel. And everything else shouldn't be connected in any way to mains live. Okay, that looks good too. Now I will have to move over, change the perspective a little bit. So my mains earth should basically have a connection to everything metallic inside here. So first, of course, to the case itself. and to each of the heating elements. Yeah, there I get a real good connection here on the copper. Yeah, these copper straps here, they sprung copper straps to the bath itself, they're a little bit paranoid, because if there's an insulation failure in here in the heating elements, and I've grounded the heating elements, yeah, ground strap is coming in here, I have a copper strap, yeah, over to the other heating element, everything should be fine. So this is, yeah, maybe a little paranoid, but you never know, do you? Okay, now to the interesting part. We will put some mains AC into this thing, and we have a look if, yeah, the temperature switch actually cuts out when it gets too hot. So I prepared everything. I have a thermocouple here, yeah, with some isolation on the top, taped down with Kapton tape. Yeah, temperature will be displayed here. And I have a voltmeter across my temperature cutout switch. So when that switch activates, we should see here mains AC, otherwise very low voltage, just the contact resistance of that switch here. I cabled up, wired up my, is it right? Yeah, mains earth, mains neutral, mains live to a power cable, which I will now plug in. Nothing happening yet, and now I flip the switch. Okay. Nothing happening so far. But for the temperature rising. And we expect, yeah, within limits, yeah, of the measurement accuracy, cut out between 115 and 125 degrees C. And there goes my thermocouple. So I will hold it in place, which is not exactly easy. Things getting hot here. And cut out. Perfect. And temperature is sinking again. Slowly. I mean, this gets, oh, yeah, I do see a problem here. Actually, my heating elements, yeah, that one here, that came off. That's an annoyance, and the other one also came off. Okay. I'll guess, yeah, while this was all very nice, I guess that officially high temperature, and yeah, I switched off. I guess that this high temperature stuff here, glue, is not really working at those high temperatures, huh? So I probably need a plan B. And I will not curse now, loudly. I will not. So, till I fixed that problem somehow, by... Wait. Okay, I run a few rounds around the block, even in these Corona times, and post-mortem failure analysis. So, first of all, you noticed that the temperature here I measured was shortly at about 140 degrees, a little bit over, which was not the intention. So the thermal cutout should have, cut out at 125 degrees latest. And then you have a little bit more heat flow here, but that shouldn't really, let the temperature bump off to 140, 145 degrees. Okay, and at 150 degrees we get at the limit that the adhesive can take. So I will probably have to tune down the temperature cutout considerably. Number two, I mean, it's been a few days, I think, when I actually glued that stuff together, but it hasn't cured completely. Okay, so where it has cured, it has a mediocre adhesion sticks not very, I mean it sticks but not very well to the stainless steel, while it sticks really good to the heating plates. Okay, so and the reason the whole thing came off was that at some point the stainless steel got so hot, and you see the outer frame, near the edge here, where there's more mechanical stability, it stayed on without any problems. But as the metal expanded, it bulged a little bit. It bulged, and that in effect, threw my heating plates off. At least, lifted them off on one side. So, conclusions. We learned a lot, but mainly two things. First, obviously, you see here areas where there is no glue at all. But so I was using not enough thermal glue. Okay, so I basically ordered twice the amount for just the heating plates. Second, we should stay in the temperature range where thermal expansion is not really an issue with the stainless steel bottom of the bath. So I will choose a thermal cutout that has a lower cutout temperature. And now I can access the screws from the other side again, so it's no problem to replace it. It's also connected only with quick connects, so no problem at all here. So not all is lost. I learned a little bit, so thermal cutout lower and definitely more glue. So will be a while until I take that project on again. But till then, bye.